Hey everyone, my name's Sebastian McKenzie. I'm from Australia, but I'm based in London, and I currently work for Facebook on JavaScript infrastructure. So what I'm going to be talking to you today about is Babel and how it relates to Ember, as well as how Babel and Ember can work together to improve web standards, and I'll talk a bit about the future. So first off, what is Babel? Actually, before I get into that, how many of you actually use Babel with your Ember apps? Awesome. All right. So for those of you who don't know what Babel is, it's a general purpose JavaScript compiler. It's primarily used for transpiling JavaScript syntax in a syntax that works everywhere in older browsers. Babel is also used for optimizing and minifying code for production, linting, type checking, and instrumenting code. Its parser can even be used for stuff like syntax highlighting and documentation generation. So it's kind of a platform of its own almost. There are all sorts of cool things you can build on top of Babel with plugins, and people are using them to create some really cool stuff. So Babel and Ember have a pretty long relationship, at least in terms of age of JavaScript projects. So Ember was actually one of the early community that decided to adopt Babel, then 65. In fact, the Ember community has always been one of the early adopters of experimental or new syntax features. Brian Donovan built this awesome tool called ESNext, which was started in early 2013 that Ember CLI used before 65 even existed. So in September of last year, I started this little project called 65. It started off as a learning project, so I wanted to learn the ins and outs of JavaScript, how it worked, as well as do something more computer sciencey, learn how parsers and compilers worked. So fast forward a few months, and 65 kind of has some stuff going for it. There's a few dozen people downloading it every month, every couple of weeks. Downloads spike every couple of weeks, and then there's like a blog post or something. And at this point, it had a good amount of ES 2015 features implemented. And the feature implementations were getting closer and closer to the specification, so they're becoming more and more compliant. And this is when Stefan Penner from the Ember core team first reached out to me about 65 joining forces with ESNext. So at the time, there were a lot of performance concerns with transpilation. Even though 65 and ESNext were architected pretty differently, both had more or less the exact same goals in mind. So outputting readable code, being very easy to use, these are all goals that both projects shared. After we emailed each other back and forth for a little while, we agreed to meet over a Google Hangout and talk about possible ways in which we could collaborate. We talked about potential goals of each project and basically established that we both wanted the exact same thing. So the meeting went really well, and 9 days after the meeting, we announced that ESNext was merging with 65. So this was the beginning of the relationship of Ember and Babel. So what's cool about Ember is that it's not afraid of adopting new technology and features, and more often than not leads the way. So this is a commit I found from the start of last year. I'm not sure if it was the first one, where Ember Core is actively using ES 2015 ports. It seems only this year kind of that people who aren't the Ember community have started adopting it. So communities like the React community have really started embracing imports, but Ember's kind of been doing it for quite a while now. And that's extremely awesome. More often than not, so the Ember community embraces new language features very carefully. So not using things when they're too immature, so using things when they're much more mature and stable, less likely to change. Since Ember's being used for a lot of production apps, you obviously don't want a lot of unnecessary churn, especially since web standards move pretty fast. And that can add up to pretty high development costs. So after Ember adopted Babel and made it a part of Ember CLI, a lot of people started to follow. So it wasn't long after when we started talking to a lot of other projects, communities, and frameworks. So we went to Facebook and met with the React team, then to Google and met the Angular team. So this became a very frequent thing over the next few months, and now Babel is used by developers across almost every framework and toolchain. So this also led to Babel getting more involved with standards. As Babel started to implement future proposals past ES 2015, it started influencing them more and more. So when Babel implements a new feature, it allows people to test drive it immediately. So developers can try out the newest and shiniest features without worrying about browsers and implementing it first. So shown here is a list of all the stage 0 proposals. Not all of them are applicable to Babel, but you can see how many proposals are currently up for debate for inclusion in JavaScript. Most likely, not all of them will make it, but some of them will, and it's important to kind of test these features out as early as possible. So this process of experimentation leads to more battle-tested specifications before they get finalized. So it provides valuable early feedback to the standards committee, which greatly reduces the chance of making bad decisions. Since once you make a bad decision in a language like JavaScript, you can't go back most of the time due to backwards compatibility. And it highlights the advantages and disadvantages of any given proposal. So it's basically like boot camp for language features, where the bad ones kind of get selected out and the good ones proceed. So these standards are more and more being developed for the tools that exist today as part of the planning for the future. So instead of frameworks trying to implement everything themselves with more code and more APIs, they're agreeing on syntax that they can share. ES 2015 classes are a perfect example of this. So Yehuda from Ember was heavily involved with the original spec and continues to with decorators. And there's also Jeff Morrison from Facebook who is working on class properties, which React is moving towards. So together, everyone is building a standard interface for the language that can be used across frameworks and libraries. So they only need to be, these kind of patterns only need to be learned once, and then tooling can operate in much more intelligent ways based on these patterns. So what does this standards process look like? So Dave Herman gave a pretty good rundown on Twitter earlier this year of the 5 stages of any given proposal. But just like any TLDR, there's a lot of missing context, so take it with a grain of salt. But I think it gives a pretty good high-level overview. So stage 0, this is where basically proposals are born and sometimes go to die. There's no entrance criteria and there's no requirements for this stage. So using something this early is pretty risky. It's almost equivalent to using something that's just flat out non-standard, such as CoffeeScript or a whole bunch of other language extensions. Stage 1, so this is where a proposal proceeds to when interest has been shown and investigation begins into bigger picture problems, just as how it interacts with present and future and possible future editions, as well as its core semantics and its high-level API. So stage 2, this is when the committee more or less expects the proposal to be included in the standard, but there's still the possibility, obviously, that it could be rejected. Any of the proposals could be rejected in prior to stage 4. So this is around the time where it's encouraged for the community to start adopting and heavily experimenting with these new features, either via a very early browser implementation or through compilers such as Babel. So stage 3, this is when browsers really start adopting it. It's kind of common across browsers. And this stage is also pretty tricky as it's difficult to make changes to features if lots of websites start depending on them. Since you obviously don't want to break the web, and so once the web is relying on it, you can't really take it out or make breaking changes. So this is the second last stage, and it's impossible to move to kind of the next stage without significant usage. And so stage 4 is frozen. So the edition is basically guaranteed to be included in the next version of the specification, and the feature is fully shipping, basically. So at what stage does Babel come into play here? Stage 0, stage 2, stage 4? Well, the answer is that Babel basically comes into play in all of them. So from stages 0 to 3, Babel is providing critical feedback to the standards committee about the feature. And then in stage 4, once it's in browsers, Babel is basically serving as a polyfill for older browsers. Similar to this, I've kind of have questions about what Babel will do once all browsers support a given feature, as if it's kind of Babel versus the browsers, when it's more about Babel working with the browsers. So if something is in all the browsers, that's awesome, since Babel doesn't have to do a lot of the work. So it's kind of like a filter. So when you go down the stages where the browsers are kind of at the bottom and Babel's filtering out all the bad stuff, almost. So you filter out the bad features before they even make it to browsers. So Babel does a pretty good job at supporting this process, but it can do it far better, and this is what we're hoping to do with Babel 6. 6.0 has much less opinions and gives you much more flexibility over what type of transformations occur. So the first step in this is modular everything. So Babel 6 consists of over 100 core packages, all with very thin public APIs that are extremely deliberately chosen. So these modules will hopefully also ensure more collaboration with Babel on Babel core, since historically Babel has kind of been a difficult code base to get into. So there's a ton of moving parts, and while splitting everything into packages doesn't necessarily make that better, there's still the same amount of moving parts. Individual collaborators can own specific packages, and they don't need to be aware of how the entire system works. They can just be aware of how one specific module works, and they just have to be aware of the public API that it exposes. So we've also focused a lot on stability. So compiler bugs suck. Debugging issues that aren't problems with your own code is extremely irritating, and it's something that we want to avoid for all costs. So I know this probably dwarfs a lot of your Ember applications. I heard the intercom app is like 80,000 lines. That's like crazy. I can barely deal with 20,000. I can't imagine 80,000. So we're hoping that this we're hoping to improve this like test coverage well into the future to ensure there's little friction as possible in using Babel. So Babel 6 has nothing on by default, literally nothing. So if you pass code through Babel 6 with no options enabled, you will get the exact same code on the other side. So this was an extremely deliberate choice. So in order to set Babel up to be a platform for JavaScript source code tooling, it can't have any opinions at all, not about what actually applies to your input code. Since what people want Babel to do will be constantly changing, and this chasing a moving target is basically what made 6.5 change its name to Babel, since every year we'd have to update the name. And this is basically what we'd be doing. We'd have to change what was enabled by default when it became commonplace for browsers to support it. And it seems weird to kind of make those assumptions and opinions for developers who have a wide range of target environments. So not only does Babel 6 have less opinions, but it encourages community and user-land experimentation. So all the core packages are using the exact same APIs that are available to user-land. So there's no secret powers that the core packages have that user-land packages don't have access to. So Babel 6 is also faster. There's no numbers on this slide, mainly because it depends on your environment, and I don't want people quoting me if it's slower or something. It's just faster, trust me. So Babel 6 will also come with updated proposal implementations, including that for Yehuda's decorator proposal and Jeff Morrison's class property proposal. It will also add support for Yehuda's later proposal, callable class constructors, that was presented at the last TC39. This allows classes to specify behavior for when they're called. So by default, ES 2015 classes throw an error when they're called. So this fills a crucial piece of missing functionality that you haven't previously been able to implement. It also allows much easier creation of factory classes and stuff like that. So plugin options are also another new feature. So this is a way to provide options on a plugin basis rather than just having one bucket for options. So this is a critical piece of functionality if you want a composable system of plugins, which Babel 6 is hopefully going to be. So it allows much more granular control over how a plugin behaves. So a plugin can be much more powerful and you can customize it more. Since Babel 6 has all the transforms as opt-in, it makes it quite annoying to have to write your own config. This is kind of a common problem where config hell, where there's a lot of repetition between multiple users over what they actually specified in the configuration. So because of this, we've added presets. So these are shareable user configs that can specify any sort of options that are then merged into the root options. So for example, this code that defines the ES 2015 preset option, the module for that would look something like this. So basically it just exports an object that's then merged back into the original options. So one important thing to note about presets is that you don't have any control over what is actually included in a preset. So it's basically all or nothing. One of the goals of Babel 6 was to remove all options that would basically change if a plugin was enabled or not. There was like half a dozen that determined whether a plugin was enabled or not, which made it really weird to reason about. You could blacklist plugins, you could whitelist them, you could enable optional plugins that weren't enabled by default, and then how an optional plugin worked if you had a blacklist or a whitelist, and it's just, there was way too many moving parts. So you basically have to take everything, and then if you don't like what a preset offers you, then you probably shouldn't be using that preset, and you should just copy and paste it or something like that. So we've heard about all the goodness that will be in Babel 6, but when is it going to be released? I've been saying soon for a very long time, but I can promise that it's coming. Soon. Very soon. Now soon. Let's do it live. Let's ship Babel 6. This is a speed test from the Wi-Fi. Note the 0.95 megabits upload. I'm uploading 100 packages to NPM. Yeah, pause your torrents. So, all right. Oh. Wait, what? I cannot see what's happening. You have unstaged changes. I wonder what I've changed. All right, I've changed the version. I have tested this kind of. I commented out all the npm execution commands. So it works locally without all the npm commands. So if it breaks, I'm blaming npm, since that seems to be a common thing that people do. Make publish. All right. Whoa, what's going on there? Oh, npm. Okay. What should I do? I get pulled before, so I'm actually not sure why this is happening. Oh well. I'm gonna get pushed. I'll force push. That's probably gonna go wrong. Oh wait. I need to do force version equals 1. All right. So previously, when I'm developing Babel 5.x, I would push releases sometimes up to multiple times a day. And somebody asks how I did that. Basically, I've just automated everything. So I just run make publish. It'll run lint, and then it'll run all the tests. Since really early on, I'd push really bad releases, since I'd be really eager to push a new version, and I wouldn't bother running the tests. So this kind of forces me to. And see red dots there. Shit. Sweet. The test fixtures. So let's. Yeah. Sweet. I'll just fix the tests. I'll just change what. I promise it's not as like. All right. Oh Jesus! What? I've got like a whole bunch of unstaged files now. All right. Let's just amend last commit. Git push -f. Publish it again. So I don't think I finished what I was saying about the publishing. Yeah, so I've automated everything, which makes it really easy to push releases. Please work. All right. So far, so good. Ah, oh, damn it. I'm going to be doing way too many git force pushes today. I don't really know how to use git. Who does? Am I right? No, you probably do. Okay. This is really anticlimactic. I'm sorry. I thought it was either gonna work. I thought it was gonna work on the first try, but I was obviously way too optimistic. Yeah. This takes too long. I'll probably just skip it or something. I just realized after it runs a test, it's gonna try and build it. Which, fun fact, I've got 100 packages, but the build system is implemented really weirdly, so it actually spins up a separate node process for each package. So at the exact same time, so after I enter in 6.0, it's probably going to like use all my RAM because it's going to open 100 node processors that are going to use like more than 50 megs of RAM. And they're all going to be thrashing my disk. So my computer might go unresponsive for a bit. I've got a lot of RAM, so I haven't bothered to fix that. Yeah. Come on. Oh, okay. All right, it's publishing. All right, come on, Wi-Fi. If it publishes one package, then I'm just going to consider that it works, and then I'll just go back to my presentation. This is. Oh, yeah, it worked. Okay, first package. So right now, if anybody tries to install Babel before all the packages are published, it's going to break. I don't know how many downloads happen in a day, but I think there's probably like maybe hundreds of people probably running into this, maybe. It's like, okay, I'll go back to my presentation for a bit. Yeah, NPM's fault. Hurry up. All right, let's go back to it. Sorry about that. All right, so let's talk about the future a bit, post Babel 6, once it's finished. So Babel 6, since it's establishes Babel to be more like a platform, hopefully the better tooling will become of this. Either existing tooling might adopt parts of Babel, or somebody might build a new tool built on top of Babel. And these are kind of some of the tools that you could possibly build that would be a really perfect fit on top of Babel. As well as since there's like a big focus on plugins, obviously the plugin API matters a lot. So a lot of focus is going to be put on adding in more powerful APIs, such as being able to do asynchronous transforms, being able to pass your entire dependency graph to Babel, so plugins have access to basically the entire dependency graph. So something like EmberCLI could hand off knowledge about every single file, and then a Babel plugin could optimize something about your code base. And as well, possibly doing something like type checker integration. So possibly not just type checking, but stuff like type inference. Even if you don't have type annotations in your code, plugins may still be able to perform certain optimizations or perform certain transformations based on type information that can be inferred. And if any of this sounds interesting to you, get involved. Babel 6 is hopefully going to be much easier to kind of get into and work on. So yeah, wait, let's just go back. All right, still going. Let's just consider that it worked. Let's push the website changes. Oh, I bet you somebody. All right, I don't want to have to git force push. All right, okay. Somebody actually just made changes to the website in between then. All right, okay, so that worked. So the Babel website is now on 6. All right. All right, yeah, thank you everyone. Yeah.